Hello everyone. So in the last video we solved merge sorted array, and in this video we are going to cover remove element. Okay, so in this question we are given an integer array nums and an integer element that is value. Now we have to remove all the occurrences of val in the nums in place. The order of the elements may be changed. So this is an important line. Now then return the number of the elements in num which are not equal to val. Now consider the number of elements in nums which are not equal to val be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of the num contain the elements which are not equal to val. The remaining elements of the nums are not important as well as the size of the nums. Now we have to return the k. Okay, so now let's see the example. So in the first example, we are given 3, 2, 2 and 3 and the value is 3. So these two elements, the element at the first position and the last position, these are the two elements which equals to this val. So what we have to do is we have to shift these two elements from the start and then return the total number of elements which is not equal to this value. So the output will be 2. So these 2 and 2 are shifted to the starting positions and the rest two positions we don't care about. So let's see example 2. In the example 2 we have 0, 1, 2, 2, 3, 0, 4, 2 and the value is 2. So all the elements which have value equal to 2, we don't have to care for those elements, and what we have to do is other elements we have to shift. Okay, so for example here these two elements we have to push these two elements at the last and move these element 304 after this element 1. So it will be 0, 1 and then 304. Okay, so 304. So I told you that the order of the elements may be changed. So that's what happened here. So it is 0, 1, 0, 1 and then 304, which is 403. So order, since order doesn't matter, so what we have to return is the length of this array, that is 2, 4 and 5. So we'll be writing two solutions for this. So let's write the solution for this. So let me give you a mental picture of this solution. So we will create two pointers. The first pointer will start from the 0th index and the other pointer will start from the last index. So what we are going to do is we will move the first pointer such that the position of that pointer will be on the element whose value is equal to the val, and we will move the last pointer toward the first pointer in such a way that pointer will lie on an element whose value is not equal to value, and finally we will swap those two elements and we will continue this cycle. So now let us write the code. So first we will calculate the size. These are the two pointers. So the other pointer, that is j, will start from the end and we will calculate all the elements which has value equal to val. So initially it will be 0. Now while these two pointers are valid, so I will be starting from the start, j will start from the end. Now what we will do is, as I said you, we will move the I pointer towards the j pointer in such a way that it will stop at an element whose value is equal to val. So if I is less than sz and nums at I is not equal to value, we will keep on moving. Okay, so the I will stop at an element whose value is equal to val. Okay, now I is at the correct position. Now we will move j towards I in such a way that it will stop at an element whose value is not equal to val. So while j is greater than I, since j will move towards I, so j must be greater than or equal to I. It cannot go before I. And nums at j is equal to value. Then what we will do is we will decrease the j and also increase the count of value. Why? Because at the position j, at the nums j, we found an element whose value is equal to val. So we have to increase the count val also. Now at this position, we have to check if I and j are still valid or not, because it might be the case that, for example, nums at I is not equal to value and it keeps on increasing the I. So I will go beyond SZ, which means I is invalid. Similarly, J can near I or J will become equal to I. And in such a case, J minus minus means, which means J will be smaller than I. So we check if J is still greater than I. So if J is greater than equal to I, which means the pointers are still in a valid position. So what we will do is we will swap. We will swap num set I and num set J. Okay. One more thing here. We check that if num set J is equal to value, then we increase the count value. But num set I, what if num set I is equal to value? At this position, nums at I is always equal to value. That's what this first pointer is doing. So which means we have to increase the count value for the first pointer. Okay. And here we are increasing for the second pointer. Okay. Now since the swap happened, we will increase the I and decrease the second pointer. Now let's take a case of an array where the element in the array is only 5. Okay. So I will be 0. J will be SZ minus 1. That is again 0. Okay. So 0 is less than equal to 0. That's fine. Now I is less than SZ. That is okay. And also let's say value is 5. Okay. So I less than SJ and num set I is not equal to value. That is false. So we'll come to second while loop. J is greater than equal to I. That is okay. Num set J is equal to value. That is correct. So we'll reduce J. Now J will be what? Minus 1. So we'll increase the count value. So J is minus 1 and count value is plus plus. Now here J is greater than equal to I. So J here will be what? Minus 1. So minus 1 is greater than I. I will be 0 here. So this condition is false. So what we will do is we will swap. So num set I and num set J will be swapped, and post that we will increase the I and J and we'll increment the counter for count value. And finally we'll return size minus count of val. So let's see if this works or not. Okay. And our solution got accepted. Now let's see the approach 2. So in that, what we will do is we will still create the size variable, that is size, and we will maintain another field index that will start from the 0. So why like this field index? So first let me tell you. So it is given that the order of the elements may be changed, and it is also mentioned that the remaining elements of nums are not important as well as the size of nums, which means those elements whose value is equal to val are not important. Do whatever you want to do with them, but all they care about is those elements whose value is not equal to val should be positioned from the start, and we have to return the count of those elements. So what we will do is we will start filling those elements from the index 0. So from index 0, we'll start filling. If the value at nums I is equal to value, we don't care about that. So we'll continue. Else what we will do is nums at fill index plus plus is equal to nums at I. So finally we'll return fill index. So I'll explain you what I did. So first let's see the result of this. Okay. So now let's see. So the fill index 0. So fill index is nothing but we are filling those valid elements. So for example, let's see this example 3223. Okay. So in this array, our fill index will be initially 0. So what we have to do is we have to check those elements only whose value is not equal to 3. So initially the first element has value equal to 3, which is our this check, which means we will continue to the next iteration. In the next iteration it will be 2, which is not equal to value, which means we have to add this element at the fill index. So fill index is 0, which means our array will become like this: 2 comma 2 comma 2 comma 3. Okay, now we'll increment the fill index. So fill index will be 1. Okay, so now this will be the element. Okay, so here this element is not equal to value, so we have to fill this element at the fill index. So the next array will be like this. So this element is filled here at index 1, and the fill index will be 2 now. Now the next iteration, the element in the iteration is 3, which is equal to value. So we will continue and finally return the fill index. So fill index here tells us that we filled 2 positions. The first position is this one, and the second position is this one. So now let's see if this works or not. And our solution got accepted. That's it.